Greetings and welcome everybody to Chapter 2, Lesson 2-1, Writing Equations. Today's learning targets: translate sentences into equations and translate equations into sentences. How do you know you're going to be successful? Well, at the end of this thing, you should be able to parse operations, variables, and quantities from a given statement or a problem to generate a multi-step equation. Similarly, you should be able to parse operations, variables, and quantities from a given multi-step equation to generate statements or problems. So with that said, keep keep these series of questions in mind as we proceed, for we will need to keep these in mind as we build on our equation knowledge and we go toward the path of more and more complex equations. But keep this in mind here. What symbols are used to represent an unknown quantity? Okay, what key words in a problem will identify the placement of an equal sign? What key words identify operations in an equation? And what does the variable in a real world problem represent? Keep all of that in mind, for they will guide us on our path to success. Now, with that said, let's dive in, guys. All right, so to write an equation, one of the first things you must do is identify. So identify the unknown variable, or well, I should say the unknown for which you are looking, and assign a variable to it. So assign a variable to it. Okay, so to get a sense as to where to place your equal sign in your equation, okay, here's some keywords to keep in mind. You'll see things like the word is. You'll see things like the word is as much as. How about is the same as? How about is identical to? You could also say is equivalent to. There's so many words, there's so many phrases, guys, that I can't possibly list them all. However, understand they will appear. Many of them will appear. So it's good to recognize them immediately as upfront as you possibly can. In fact, when I dissect word problems and statements, the very first thing I personally look for is the equal sign. Then I look for the unknown and build out from there. So actually, let's sort of try a couple examples here just to get our appetite a little wet here for what is to come. So we're going to start fairly basic and build our way up to developing a word problem. So let's see here. Let's look at this here, this phrase here. This literally reads as 7 times a number squared is 5 times the difference of k and m. And I just got done saying, I tend to look for the indication as to where my equal sign will be. I look for words like is or is as much as and so forth. So I found it right here. In this little phrase, this is where my equal sign is. Again, I like to do that. You can sort of build out from there or try a different approach if you like. But for me, this gives me a sense as to the clear division here, and you'll you'll see as you get more and more complex and problems. I think this is generally the best approach is to start with the equal sign. Now from there, I want to find out my variable. I want to find the unknown. The whole purpose of word problems is generally to determine the value of a variable that you do not yet know. So I want to get a sense as to where it's at in relation to my equal sign. If I sort of look over here, I see 7 times a number squared, a number. Well, a number, it's not clear as to what the number is. In fact, it is intentionally stated that way as to be your clue that this indeed is your variable. So I'm going to place x here to represent that, a number. Now in this case, it is a number squared. So I'll go ahead and put that there for now. Let's see, and the rest of this here and the rest of this here. Okay, I see quite literally letters or variables here too. I'm gonna go ahead and, well, actually, let's talk about this here for a second. All right, pay close attention to phrasing such as this, the difference of k and m. Students will often, you know, read that statement and they will come up with this, the difference of k and m. Now, let me build the rest of this out and I'll show you why this may not be the correct answer. Let me go ahead and build the rest of this out. So after I do variables, I look for quantities. I got 7, I got 5, and then I look for operations that may exist here. In this case, times indicates multiplication, times again multiplication. Okay, so let's talk about why this may not be ideal. This one here, how we came up with, k minus m from this and represented it exactly in the way that we did. So you should remember from order of operations. Let me look at this whole side of this equal sign, right? You should remember from order of operations that if you had this, which is what you actually do have, the way that this is represented, you would come up with 5k minus m, right? I mean, that's multiplication and subtraction, but, but, what if I did this? What if I did this? So if I did that, then it would quite literally look like this. And you know from applying the distributive property, you give your 5 to your k, you give your 5 to your m, and this would end up being 5k minus 5m. You see, there is a very clear and distinct difference going on here. This is what we just got, and this is what we had before. 5k minus m is not the same as 5k minus 5m. Therefore, it's very important to pay very close attention to the specific phrasing used here. The specific phrasing, when you see something such as the difference of k and m, right? Specifically that phrasing, the difference of, the sum of, it should be your clue. It is your clue to put the quantities in, or the variables in this case, in a set of parentheses. And you see the importance of doing so. If you don't, you will get a completely different representation as to what it really is. If you do, then you'll get something more correct. If you take phrases and sentences and convert them into mathematical symbols and variables and on, if that part's not correct, the whole rest of your problem's not going to be correct. So it's very important to recognize key phrasing when it appears. So again, I just wanted to reiterate this sort of phrasing here, the difference of, the sum of, parentheses, guys. All right, so that's that. That's that one. Not too bad, right? Not too bad. Let's look here. Let's do another example. Let's see, 15 times a number subtracted from 80 is 25. First thing, I look for is words such as is. I want to figure out where my equal sign is. So boom, there's that. Now I can tell that I got all this stuff on this side, and I got this thing here, here. So let's see here. Is there a variable? There should be. Where is that? That's what I want to locate next. 15 times a number. Aha, a number indicates variable. Go ahead and put X there for that one. Let's see, okay, and then the rest of these are quantities. I got 15, I got an 80, and I got a 25, and now let's look for some operations that are happening between these things. So 15 times, okay, so multiplication there. Let's see, subtracted from. Now, pay attention again to the phrasing. Students will be tempted to put this. However, this is not quite exactly right. And in fact, I would say, I would say this sort of phrasing here, I can absolutely see where people would be led astray, right? That specific phrasing, it's not quite clear if you haven't been working with this stuff for a while. It's not quite clear, okay? That there. But let's rearrange this a little bit. It is acceptable to rearrange this a little bit in a way that makes more sense, in a way that is, especially if it leads to higher rates of accuracy. And in this case, rearranging it will indeed lead us to more of a correct solution here. So I'm going to go ahead. So I've sort of already rearranged things in the way that this problem is really trying to convey. So let's go back here. Is, okay, got my numbers. I got my numbers. Oh, I got my variable here too. All right, so 25, and then now here's where the key difference here is though. This, how this is different from this one, minus. So 80 minus 15x, or in other words, let's see here. Well, how does that make sense? How does that make sense? Well, let's think about this. 15 times a number is subtracted from 80. Is subtracted from 80. When you say it like that, it becomes a little bit more clear that, wait a minute, 80 is the big number, and you're subtracting something from that 80. Again, students will be tempted to put just a plain minus sign. Subtract, they see that word, and this is their automatic thought here. Understand this will lead you to an incorrect answer. This one is a little bit more, when you rearrange it and maybe put different phrasing, which is what we've essentially done here. When you put different phrasing, subtracted from, minus, and then, you know, we rearrange some letters, we put that over there, we put this over here. When you rearrange and maybe rephrase, it becomes a little bit more clear. This here is more clear at a first glance reading to a reader who may not be well versed in the language of mathematics like you guys are. It's clear, it's logical. Therefore, pay attention to phrases like this, subtracted from, especially when it comes to subtracted from. Added to is not as much of a big deal, but subtracted from has very big implications here, because if you solve this first one here for your variable, essentially you're going to get the number may be correct, but the sign is going to be off, and you don't want that. So there you go. There's sort of that one. Let's look at another. Let's look at another here. 2 plus the quotient of a number and 8 is the same as 16. How do I put this into equation and numbers and variables? How do I do that? Well, let's break it down. Our steps, our process. I see this immediately jumps out at me. Is the same as. That would indicate an equal sign is happening here. Let's see here. I'm seeing my variable is mixed up in this whole thing here. All right, this phrasing, a number, is the indication that I have a variable going on. Let's see, let me think about this for a second. The quotient of a number and 8. The quotient of a number and 8. Well, quotient would indicate some sort of division, right? We represent division with some sort of number and a number, kind of like that, right? Sort of like this, like a line and two numbers arranged in that way. Okay, so I know it's going to involve that somehow. Of a number and 8. Which one goes where, though? That's the question here. Well, it would actually be x is the one that goes here, and 8 is the one that goes here. Quotient of a number and 8. So I found out my variable. Okay, all right, now let's build out the rest of this. 2, I got numbers here, I got numbers here, and operator. Let's see, that covers everything. That covers everything, guys. Perfect. Absolutely perfect. This is how it should be represented. Not too bad, guys. These aren't so bad. Now we're gonna use this information, and we're going to get a little bit more complex. We're going to build on this a little bit more. All right, here's one more though. Let's get this. Let's get this one under our belt, for we will see this a little bit more. Well, it's just another way that we've kind of been, it's just another version. Let's do this one here. Let's get this one under our belt, then we're going to build on that a little bit more. So let's see. I start with is, or words that would indicate where my equal sign is going to be. So right away, this jumps out at me, is. All right, then I look at potentially where's some variables at. Well, this k here is fairly clear that this is a variable. All right, let's see here. H squared, again, clear. It is quite literally a variable. H squared, okay? Now I don't see any more variables. Now let's talk about numbers here. 27, 9. Okay, now operators here. Times, okay, time multiplication. There's my little multiplication sign. And decreased by, decreased by. Well, this would indicate, just like from before when you had the phrasing subtracted from, that was a phrase that indicated some sort of subtraction operation was happening. This too is a phrase that indicates subtraction operation is happening. These are different, however, and it is key to recognize that these are in fact different. You see, subtracted from would mean that whatever was mentioned before is, you know, being minused from this other thing. So your math would end up looking like, let's call this one A and this one B. And so the math on that one, again, would be A minus B. The difference here, decreased by, there is no, it would just be a quite literal minus sign. There is no, I guess, trick really, or deeper understanding to take from it. It is, when you see that phrasing specifically, decreased by, that is your indication that a minus, just a straight up minus sign right there, is perfectly acceptable. So these phrases will be used interchangeably as you go through the different problems. So again, it's important to keep these in mind, pay close attention, for you will see all sorts of different phrasing. Now I think we've covered much of the basics. Let's start again, where our whole goal here is to build up toward writing a word problem. And so let's start building in some words, add some more, right? We're gonna add some more to what we've been doing thus far. If you think you know, go ahead, pause the video. I'll give you a second. All right, welcome back. So we are going to work these together now. Let's see here. The sum of 8 and Mabel's age is 62. I see is. So boom, that indicates there. The sum of, just like we had the difference of, see the sum of 8 and Mabel's age. Okay, let's see. Oh, they tell us that Mabel's age is M. So the sum of, just like the difference of, you want to put parentheses. Now mathematically, they may not always be mathematically necessary depending on the rest of what's going on, right? If you had a multiplication happening here, it would absolutely be necessary, but that doesn't appear to be the case here. But best practice is to always put the parentheses as you're building this thing out, and then as you're preparing to solve, reevaluate if those parentheses are still absolutely necessary. With that said here, let's see, I got my variable. I basically got this whole side of the equation done. I just got this one to focus on here, this side, and all that's here is just a plain old 62. So here we go. That's it, right? We're building up to a word problem now. We're throwing in names. Interesting, interesting. So the difference of Helena's age and 2 is 26. Oh, okay. I just mentioned the sum of, the difference of, here we have the difference of. So let's see here, the difference of Helena's age, which is H. Oh, wait, hold on. Let me start with my equal sign. How dare I skip that? Let's see, is. Okay, there we go. Is, okay. Helena's age, H, and 2. Now, I want to point this out specifically, actually. I'm glad this is here. Generally speaking, if you see, let's say, H and 2, that would indicate an addition. That the word and is a indicator for an addition operation happening. However, that is not the case in this particular one because immediately before this, it talks about the difference of, right? The difference of. So, in fact, this one would be minus 2. If there was no the difference of, if this was just simply Helena's age and 2 is 26, then this is the right way of representing that. But because you have that phrasing right before this whole thing, and that is your indication that the two quantities being anded are subtracted. So I would just wanted to point that out. Now let's see, let's finish this out here. Is 26. There you go. That's it on that one. Nothing too bad at all. All right, this one here, 96 is the product of Rick's savings and 6. Okay, well, I'm seeing the word and here, as I just mentioned. And would typically indicate, right, that would be S, that would be 6 right here, plus, and would indicate a plus sign, an addition operation happening. But just like the previous example, you have some special phrasing right before it introduces this phrasing, this and phrasing. It has the phrasing specifically, the product of such and such. Okay, the product of. So this phrasing in front of it, the product of, the difference of, the sum of, it would override what you would typically think of as being and it would be relating to what this is, just like it related to what the difference was, right? The difference being subtraction, the product being, you ready for this? Multiplication happening. So it would indicate that there's multiplication happening. And I had my is and 96. So 96 S times 6. There you go. That's that one. Let's see. The quotient of Vidya's age and 7 is 112. Okay, so is 112. Is. Okay, there's is. Let's see. The quotient of an age and 7. Just like the other one from before, we had, if I recall, it was, a number, whatever that number was, number and, 8, right? So the first term, thing, the first thing is the one that's on the numerator or the top, I'll say. So that's my variable. Age, V, and 7. There you go. Is 112. Or, yeah, is 112. Okay. Yeah, that's it. That's the whole equation right there. Guys, not too bad at all, right? Not too bad at all. We're building up. We're building up. We're developing our skills here. Okay. Let's throw some geometry in this thing, guys. Let's throw some geometry connections going on here. So, here we go. There's no difference. Yes, it's geometry, but it's the same stuff. Let's see. The area of a triangle equals the product of 1/2 the length of the base and the height. Well, this is quite literally equals sign. That's nice and convenient. Let's see. Now I'm looking for variables here. The product of, well, I actually might have a couple of variables here. Let's see, the area of a triangle. I don't know what the area of a triangle is, so I'm going to represent that with a variable, but you could just as easily put a whole word in its place. I'm going to say A for area. Maybe I'll just use the whole word. There we go, area. Okay, now the product of 1/2 the length of the base and the heights. Okay, base and heights. Now remember, right? And would generally indicate addition happening, but keep in mind, we have this phrasing preceding it, I should say. So that changes the game a little bit. That would indicate that you must not use addition, but instead use the operation indicated by this word specifically. So I see base and height. I should see, I'm gonna use B to represent that, by the way, and I'm gonna also use H to represent this. So I'm gonna say base, not and, not plus, okay, not plus, but multiply. Because why again? This. So there I go. The product of, I generally, remember, I put these things in parentheses, just like the sum of, the difference of. Oh my, I didn't put that there. I apologize. There we go. The difference of such and such, the product of. Oh, I'm in slipping here, guys. All right, there we go. Product of, difference of. You should get in the habit of putting them in parentheses because they could have, the lack of parentheses could, as we saw earlier, have a dramatic effect on what the actual outcome of the equation and the variable solution will be. So get in the habit of doing that. Okay, so we have the base and the height, and then it has this thing here, 1/2. Well, 1/2. Now it actually was very important to have the parentheses here because, again, distributive property, 1/2, 1/2. Well, actually, well, it wouldn't matter as much because these are being multiplied. If these were added, though, yeah, that would have a huge impact. Okay, so I take that back. It's not as important, but still quite important. Get in the habit, guys. There we go. That is it. That is the equation right there. It may, if you are familiar with geometry and you've worked with triangles before, this may look a little familiar to you. You may have seen it written like this many times, 1/2 base times height. This may even sound familiar. All right, let's look at the next little bit here. Let's look at the next little bit. Again, a geometric connection here, guys. We like to connect things all across the curriculum, not just algebra, but geometry, for they are both intertwined. Let's look at this here. A right triangle, right triangles, they look like this. Oh, my artistry is not the best here. Let's see if I can do it. There we go. Right triangles, they look somewhat like that, right? Let's see, anyways, the square of a hypotenuse C is equal to the sum of the squares of the legs A and B. Well, first thing is equal to. That's where my eyeballs go right away. Okay, the sum of or the square of the hypotenuse C. Well, it tells me the variable to use and the letter, which is nice. So I'm going to use that, C. And it says the square of it. Okay, the square of it. Nothing complex there. Here we go. The sum of that phrasing. I'm going to go ahead and put some parentheses right away so I don't forget. The sum of the square of the legs A and B. The sum of the, okay, so I see that word and just by itself. Okay, usually it would indicate plus in addition, but I have to default to the phrasing out here, which indeed in this case is the sum of. So it would indeed be A plus B. But not just A plus B, I have to keep in mind also, it talks about squares. Squares of those things, A and B. Squares of them. So these two items are squared. And as it turns out, this is the equation for determining the hypotenuse, or, well, it's actually the equation that relates the legs, which is these, of a right triangle to this is called the hypotenuse. But in any case, maybe you've seen this before, maybe not. That's it though. Like I said, I remove my parentheses. They're not, now that I've built it out, I recognize they're not as essential when it gets to the equation solving process, but when you're building it out, it is absolutely essential until you figure out fully, build it out fully. So you will typically see it represented as this, if you are familiar with geometry at all. All right, let us proceed to the next one, guys. A few more examples. We're going to build up a little bit more. Here we go. Let's try this one. Actually, we've kind of taken all the different ways to take words and make them into math symbols. Now we're going to do the reverse. We're going to take the math symbols and make them into words. And here's where you're going to get a ton of potential variety here, right? And I'll show you all sorts of variety that comes to my mind, but When you see these problems, they will be represented in so many ways I can't possibly cover them all here. With that said, though, let's see. Well, just as with words, I like to start, right there, equal sign. So I can say is, I can say is as much as, and so forth and so forth. I'll leave it like that for now. So let's see here. Oh, variable over here. Okay, variable. I see the variable. Okay, what's happening to it? I recognize that it is being multiplied by 6. So you could see it represented as 6 times z. That's supposed to be a z though, guys. All right. Or you could see even you could even see literally just this piece of the phrasing, the product of 6 and z. So I can leave it like that. Sure, why not? Let's see here. Got some, 15. This would be 15. This would be 45. Whoop, 45. This could be minus. This could be decreased by, as we saw earlier. Decreased by. You could even have this whole thing even further rearranged to say the difference ference, whoop, the difference of 6z and 15 and so forth. You could have it phrased like that. Again, all sorts of different ways. I think I'm just going to stick with this one as minus. Next one, let's try it out, guys. Okay, so we got a lot of variables going on here. Okay, all right, but always, for me, I always start with my equal sign, which I like the word equivalent to. So I'll go is equivalent to. There we go. All right. And again, this is one where, let's see, I have something, there's a plus sign in between those somethings. So as I just got done saying, as we've seen several times now throughout this lesson, you could literally have the entirety of this side of equation be the sum of that one thing and that other thing is blah, blah, blah. You could literally have it arranged in that way. You could see, in this case here, I want to look at these piece by piece here. So let's see, this could be simply y squared. You might see it like that. You might see the square of y. Um, yeah, I think that is, yeah, just y squared or the square of y. I don't see no other sorts of phrasing jumps to mind. But again, I can't possibly cover it all. They may come up with some weird stuff that you know, I'm not thinking of at the moment. Anyways, let's see here. This one, I see another variable. I recognize it is being multiplied by 3, and you can see it represented as perhaps maybe again 3 times x. You could also see it represented as the product of 3 and x. Let's see, this w is just all by its lonesome, so you could just leave it as w here. And then this here, you could say added to. You could say simply plus, and you can even say and. And we've seen that several times throughout, and I pointed that out a couple times. There you go. That could be one way to represent this mathematical symbology in words. Let's see. You'll also see. Oh, okay. Here's a few more. Let's not jump too far ahead. Okay. All right. You'll see this. Okay. How do we say this here? Well, let's see. I'll say is, just plain old is, or I'll just be very literal here and use the word equals. Let's see here. Oh, here's my variable right here. Okay, this one here, let's see. I could see it written as 25 times u squared. That could be one way. U squared. I could also see it represented as the product of, let's see, a product of u squared. It could be that, sure. The product of u squared, or the product of the square of u. Again, so many different ways to represent that. Let's see, this here, I could be quite literal here again with plus. Why don't I just stick with that? And then, of course, 2 and 15. Let me jump back up here real quick to this 3x because I want to point something out here. One phrasing that I didn't quite get, but it just sprung to my mind as I was just looking at this here. So 3x, you could also see triple x, or let's see, yeah, triple. So I just want to point out you could say triple, right? You like with if this was 2x, one way of saying that would be double x. So keep that in mind. That's another phrasing that just came to mind. Anyways, let us proceed further. Okay, we've got a couple more, and then I think we are ready to build upon that once we do these couple more here. Okay, this looks a little, oof, all right, wow, what's going on here? We got this, we got this. Okay, let's look at it. Well, first things first, is the same as. Okay, great. Now let's look at my variables here. I see a couple variables here. Once again, this whole thing could be represented as the difference of such and such is such, right? It could be that. That's not the case here, right? We're looking at each one individually here. So let's see here. I want to look at this one here real quick. So very similar to squares, this is what's known as cubed. So you could see t cubed. You could also see t to the power of 3. You could also see, you could see t raised to the power of 3. Same with squareds, or if you see t to the 4th or whatever, same thing. Let's look at this here. This is our other variable in play here. We can have, once again, the product of 3 halves and, I apologize for the handwriting, guys, and r. You could have that. You could have 3 halves of r, or simply 3 halves r. A few different ways. This could be, they could leave it as 132. They may spell it out 132. This one, minus, just plain old minus is fine. Okay, not too bad. Again, you will encounter so many ways in which these are written. I can't possibly cover them all in the time that we have here. But I will say we have taken a little bit of a journey thus far, translating sentences into equations, translating equations into sentences. Now I think we are at a point where we can be given minimal mathematical information and create a word problem, create a story out of it. That's what we've been building up to. And so this is the fun part, really, is that now we have a little bit of creative freedom here to look at some information and proceed from there. So what do we got? What do we got here? Okay, So create a story from, or given the following information. So listen, in this particular scenario, they're giving me a couple pieces of mathematical symbology, and I have to create a story and words from it. Let's see. Well, they give me the entirety of the equation. That's interesting. But the equation itself means nothing if I have no context. So hopefully they've given me a little bit more stuff about it. And indeed, I see that they've given me some pieces of information here about it. I have, I see in my equation there are some letter T's happening here. And it says T here, and it's given me a little bit of context and clue as to say that this is the time that Maxine drove during each of her turns. They're also telling me, so anytime I see a T, that would be representative of that. They're also telling me though that when I see this whole thing, which happens to be this, they're telling me that when I see that specifically, that is the time that Tia drove during each of her turns. Okay, so pause the video, think about maybe a scenario in which you can like put a real story together about this or make sense of the information that's happening. Pause the video real quick, see if you can come up with something. There's a few different directions you can go with this, so I'm curious to see what you come up with. Take a second. All right, welcome back. So I've taken a second here and I think I've got something. Now I just want to say a couple things that come to mind is maybe a scenario around, golfing would be potential scenario going on here, right? In golf, you drive a ball, right? And you guys take turns. You can have that. So you can do that. But the thing that most immediately jumped out to me is a scenario around car driving. So that's sort of the scenario I'm going to build. That's the context as to how I'm going to build this out. So let's see. I'm going to say, oh, good old Maxine and Tia, they went on a trip together. Went on a trip. And they took turns. And they took turns driving. Okay, so Maxine, our friend Maxine here, she took two two turns. And let me explain that here in a second. She took two turns. Two turns. Why do I say that? Well, again, anytime I see T, it's representative of a single turn that she took. But in the final equation here, the completed equation, it has a 2 multiplied by that T, indicating that two of Maxine's turns occurred. So that's where I'm getting the two turns from. Okay, excellent. And let's see, let's see here. Tia, she took one turn. Tia took one turn. Now, why do I say one turn? Well, let's see. This t plus 4 is indicated is the time that Tia took each of her turns. There's only one of these terms here. It's not a scenario in which there's a number out here like a 3, that you're distributing. 3 multiplied by that. Nope, it's just 1. So that's where the 1 turn comes from. All right, so and Tia took one turn, which I'm going to say is which took, let's see, we're talking about time here. Okay, so let's see, whoa, which took, I'll say we're talking about minutes here. So which took 4 more minutes than Maxine's turn. Okay, perfect. Let's see here. So, let's see, what else do I got here? I took care of this in my word problem. I took care of this. I got this to deal with though. Okay, let's deal with that for a second. So I can say together because this plus is here. Together, They drove for, I'll say 28 minutes. 28 minutes. That makes sense to me. Okay. So that together, here's another phrasing. Together, they drove for 28 minutes, right? So there you go there. See, together they drove for 28 minutes. How can I now make a problem out of that? Because the whole point of word problems is to make a word problem is so that you can basically sort of solve for a variable. Let me take a second to think about that. Let me take a second to think about what I may be trying to solve for in such a problem. And the variable I'm going to come up with is I want to get a sense as to how much time. So I can potentially say the question that you would be presented with in such a problem would be, potentially how much or or how many, I'll say, how many minutes was or did Maxine drive for? Did Maxine drive for? And you'd have probably a follow-up question as how many minutes did Tia drive for? You might have that as a follow-up question too, after you figure out how many minutes Maxine drove for. So we built a scenario here. That's incredible. Let's try another here to get a real good feel for this. Very similarly, very similarly here, we're presented with minimal mathematical information from which we hope to build a problem. If we can build a problem out of this, we're constructing a problem given mathematical information. We can then deconstruct problems to get the mathematical information, right? So this is critical. This is critical here that we get this and we understand this and we're successful at it. So with that said, I'm given information pertaining here. Well, here's the equation in question. Here's the final equation. That's nice that they've given me this. Perfect. Okay. But these things, these letters and these numbers, this symbology, these variables means nothing to me without context. I got to have some context here. And luckily it does in fact give me some context here. It tells me what this variable represents. It tells me that this here is Beth's salary. Okay, I like the sound of that. Let's see. Furthermore, it talks about, let's see, I'm looking at this here, so I kind of got something here. Let's see. Now this thing here, I have this thing here. Okay, what does this mean? See, this is the percent of salary bonus. Okay, interesting. So very minimal mathematical information, minimal context, but I think I can create sort of a word problem from this, a word problem which you may encounter, you may see in the future. So let's think about this for a second. Pause the video and just try and come up with something on your own. All right, welcome back. So here is sort of what I came up with to put some context around this scenario here to create a problem that you would see. So let's see, we have Beth. Beth's Beth's pretty wonderful, and she gets paid, of course. Everyone loves getting paid. And so she gets paid at her job. And she gets paid at her job in both salary, just straight salary, and let's see, a bonus. Now you could think, this could be all sorts of different sorts of professions. The profession doesn't really matter. I mean, this could be, a waitress. This could be um, a professional working at sort of a corporate role. It could be all sorts of things. The profession itself doesn't matter, right? But we're just putting a story together that makes a little bit of sense here. So her bonus, let's talk about her bonus for a second. Okay. Well, actually, let's look at this here for a second. She gets paid at her job in both, keyword here, both salary and bonus. You can see from this equation here, we have a plus sign of two different things, right? A P and then this. And as we saw, this is salary and this here is bonus. And that makes sense, that makes sense the way we've worded it here. Perfect. Okay, now we got more stuff to talk about here. Let's see. Let's talk about that bonus here for a second. Let's see. That bonus there is, let's see, bonus, whoop, her bonus is 10% of her salary. 10%, you're thinking, where did he get the 10% from? Well, understands that 10% is indeed, its decimal representation is that it's 10%, it's 0.1, right? So, in other words, 1 divided by 10, 1 divided by 10, you know, that becomes, or sorry, 10 divided by 1, and then 0.0, right? That goes in there one time, 0.1. So it's 0.1 is the point. So I just want you to recognize if that wasn't clear to you, 10%, 0.1, that's sort of how I knew that it was 10%. Anyways, with that said, Beth, now she gets paid. Let's see, or let's say she was paid, or she gets paid, whatever, was paid. Let's see, a total of $525. Okay, a total of would be another clue that things are being added. Total of, right? So the addition that is happening here. Be another clue that there's addition happening in this problem. So let's see, I think I've sort of addressed all the different the elements here. I've got that taken care of. I've got, let's see, I've got that taken care of, and I got that taken care of. So I think I've addressed all the elements that was given to us. So you would see a problem that may look something like, what is the amount of Beth's salary? That's definitely, I can easily see that being a problem you will be asked, right? In other words, solve for P. And the other one was solve for, what was the letter used? I believe it was M, or no, T, the time. Right, exactly. So, yeah, what is the amount of Beth's salary? I think you got it, guys. I believe you have now successfully gone on this journey with me in which we took sentences, made them into equations, we translated equations into sentences. And really the grand prize here at the end is we were able to construct a word problem, and just as easily we can deconstruct that problem all the same. So I hope you've enjoyed today's lesson. I will see you back on the next one. Take care, have a great day, and I will see you soon. Goodbye.